Hello everyone and welcome to McLean 360. So in this video I want to teach you the second moment of area of a rectangular cross section. Alright, so let's begin. So from definition we have the second moment of area about the x-axis, which is called Ix. Alright, now this Ix is given by the integral of y squared dA. And similarly, we have Iy, which is given by the integral of x squared, I think it's y squared dA and then x squared dA. Okay, so now let's apply this formula to the question given here. So we have a rectangular cross section. Now this is what we are going to do. We are going to assume that our rectangle is consisting of small elemental strips. Okay, so these small elemental strips can actually be taken as, some elemental areas which has been stacked up together. So we can just take one of the elemental areas, and then we are going to call the thickness of the elemental area as dy. Okay, and then dA is more or less like the area of the the element. Now what do we know? In fact, the actual elemental strip is actually a rectangle, so it's going to take the area of a rectangle, which is given by the length, which is b, and the thickness, which is dy. So b dy, and that is why we have dA as b dy. Now also we have to understand that this elemental area is assumed to be at a distance y from the x-axis. Therefore we can call that distance y. So that is why we are calling this y. So this y is sort of the distance between the elemental area and the x-axis. All right. So simply put, whenever we have Ix, we can rewrite Ix as the integral of y squared b and then dy. Okay, now this is very much simple and straightforward. And what this means is that we can actually say b is a constant, so it's going to come out. Then we do the integral of y squared dy. Now this will be very much simple. What is the integral of y squared with respect to y? That is very simple. It's going to be y2 plus 1 divided by 3. In other words, by cubed divided by 3. And what is the value of y? So you see that y is changing from y equals 0 at x equals 0, and y is changing all the way till we get to h. So in other words, we are trying to sum all the elemental areas. Think about it this way. We are trying to sum up all the elemental areas, all the small rectangles until we get to h. And that is the basic idea behind what we are doing. So from 0 to h, and that is going to be b out of 3, and we have h cubed minus 0, which is simply put is going to be Ix given by 1/3 b and then h cubed. Now it is very much important to understand that basically what this is trying to say is that whenever you have an whenever you have a rectangular cross section, then the second moment of area about the x-axis is nothing but 1/3 bh cubed. So that is actually the formula right here. But I want to apply what we call the parallel axis theorem. Okay. So we are going to use the concept of the parallel axis theorem. Okay, Now, what does the parallel axis theorem says? So parallel axis theorem. Now, basically, the parallel axis theorem is saying that whenever we have two axes which are parallel to each other, then we can say that the area moment of inertia, let's call it maybe Ixx, is equal to ICG plus AD squared, where Ixx could be any axis, but then ICG is what we call the area moment of inertia about the centroidal axis. So area moment of inertia about centroidal axis. Now, people, what we can do is that we can use this formula to find the area moment of inertia of the rectangle about the centroid. Using this formula, we can say that ICG will be ISS minus AD squared. So in other words, we want to find the centroid, the area moment of inertia about the centroid. That's all. Okay. So from here, what we can do is that we can simply go straight forward, and then we can say that from the diagram, what is our centroid? So whenever you have a rectangular area, your centroid will always be 1/2 of the area. Okay, so let me clear this. So what we are trying to say is that whenever you have an area like this, all the time for a rectangular area, the centroid will always be formed at a distance which is exactly half. So in other words, we can call this axis the centroidal axis. Let's call it CA, which means centroidal axis. And let's not forget that there is already the x-axis passing through this way. So this is the x-axis, but then this axis is what we call the centroidal axis. And the centroidal axis passes through the centroid. Therefore, the distance all over to this point is actually going to be h/2. In other words, 1/2 of the height. All right. So that is actually the centroidal axis about the x. In fact, we can do the same thing for the y, and it's also going to pass through exactly 1/2 through the height. Okay. But first of all, let's do for the x. Then we come and do for the y. So considering the x is going to be, so in this case, we want to use this formula, which we have used already. Okay. So we want to say that ICG is going to be IXX minus AD squared, which is given by IXS. We solved it already, and we're able to show that it was 1/3 BH cube over 3. So 1/3 BH cube over 3. Oh, sorry, 1/3. That's all. 1/3 BH cube minus the area of the rectangle, which is BH. So BH and D squared. So D squared is the distance between the parallel axes. Okay. So this centroidal axis is parallel to the x-axis. So the distance between this is the h/2. That's all. So h/2 squared. Then ICG is going to be 1/3 BH cube minus BH. So this one is going to be squared multiplied by this is going to be cubed 4. Okay, now let's do this together. if I have 1/3 minus 1/4, so taking the LCM is going to be 12. Then I have 4bh cubed minus 3bh cubed. And that gives me 1bh cubed, but you don't have to write 1. So we get bh cubed over 12. And this formula is very important in the study of mechanics of materials, because this formula gives us the fact that if I have a rectangular cross section, then the area moment of inertia about the centroidal axis is given by bh cubed over 12. Okay, so this is about the centroidal axis, and this is what is used mostly in questions, unless you have been given a certain axis. So if it's about a certain axis, then that one you are going to use probably maybe the x-axis. So we are going to use the formula that we got, which is 1/3 bh cubed over 12. Which is 1/3. So we already established that is is 1/3 bh cubed. Okay, so that's what I was trying to say. Now that we have done for the x, let's do the same for the y. Okay, all right. So doing the same for the y, this time around, instead of going by the x, we are going to take the elemental strip by the y. Okay, let's quickly do that. All right, so let's do the same thing for the y-axis. So this time around, the distance all the way here to the elemental area, we are going to call it x. Okay, since we are moving around the x-axis. And then don't forget that the distance from here to here was h, and then the distance all over from here to this place was b. Okay, so let's quickly do this. We want to find the iy, which is the integral of x squared dA. So what is dA? This time around, dA is the area of this elemental this element, sorry. So basically we just have to multiply. So the thickness this time around, since we are moving a thickness in the x, this one is going to be dx. Okay, so this thickness over here, let's call it dx. And then, so in other words, the area this time will be h multiplied by dx. Okay, so that is the dA. Okay, so it's going to be pretty much straightforward. X squared h dx, and h is a constant, is going to come out. So we've got integral of x squared dx, and this is going to be pretty much straightforward. So it's going to be x cubed divided by 3 all the way from x equals 0 to x equals b. So we are trying to add up all the small rectangles, along the x direction. That's all what we are trying to do. Don't forget that we are dealing with the y. So since we are dealing with the y, then it means we are going to add all the rectangles in this direction. Okay, so it's going to be 1/3 h b cube. Now I want you to realize something here. You see that with what we did for the first one, it was bh cubed, but this time around this is h b cubed. So please, I want you to be careful about this. About the x is going to be 1/3 bh cubed, but about the y is going to be 1/3 hb cubed. I hope the concept is clear. So please don't be confused. All the time when you are working with this, you have to be very careful. Now let's go ahead and find about the centroidal axis. So we can say that Iyy is equal to ICG plus AD squared. And again, we can say that ICG should be equal to Iyy minus AD squared. This time round, our ICG is going to be IYY, which is 1/3 HB cubed, minus area, which is always BH. Now the D this time is actually the centroid about the Y. And for the centroid about the Y, it's going to be, let me draw it well so that you get it. Whenever I have a rectangle, the centroid about the y-axis will always be that axis which divides it exactly into two. So that axis will be somewhere close to the center, and that axis will divide it exactly into two. And at that axis, let me put it exactly in the center, somewhere along the center. At that point, x will be exactly b/2. Okay, so we are saying that at the centroid, x will be b/2. So this is yc, which is like the y-axis which is passing through the centroid, and this is the original y-axis that we have. So the parallel axis is saying that if we have the original y-axis and then we have the centroidal y-axis, then that distance is x equals b/2. Similarly, with the y-axis, we said that, I've cleaned it. But with the y-axis, it's actually going to be the same thing. I'm sorry, with the x-axis, With the x-axis, there is an axis somewhere here, which is xc. So that distance up to the x will be h/2. And that distance is actually the distance from the centroidal x-axis to the original x-axis. But this one, we are talking about the centroidal y-axis and the original y-axis. Okay. So it's going to be b/2. So b/2 squared. Now, if you do the algebra and then you finish up with everything, you end up with so hb cubed over 4, which gives you the same thing, but this time around hb cubed over 12. So in other words, ICG is actually hb cubed over 12 along the y. So this is a summary of this video. We have learned that whenever you are given a rectangle, whenever you are given a rectangle, the centroidal, the area moment of inertia about the x-axis is given by 1/3 bh cubed, where b is the length and h is the height. Sometimes some people call the h the depth. Okay, sometimes some people call it the b, some people call it the width, and then the h, they call it the depth. Okay, but then if you are looking at the y-axis, this formula will turn around, and then instead of 1/3 bh cubed, it becomes 1/3 hb cubed. Similarly, about the centroidal x-axis, the formula that you get is going to be bh cubed over 12 about the centroidal axis, the centroidal x-axis. But for the y, the centroidal x-axis is going to be the centroidal y-axis is going to be hb cubed over 12. Thank you very much for watching.